Welcome, everybody, to this Call for Code Accessing Select Data Sources session. We're very delighted to have two speakers, Jay Couture and Hendrik Hamann. And we'll be speaking with them in more detail in a few minutes. But first, I wanted to share with you the Call for Code getting started, and just to tell you the steps that are happening at the moment that you need to follow in order to follow the next steps to do your call for code. So here we go. I think this is getting started with our kits. And there are two tracks. You can either join the COVID-19 or take on climate change. There are two possibilities that you can work with. You can get involved as a participant, and as you can see, we have many sponsors. I'm going to just jump into getting started with our toolkits here. We have the Fighting the Global Pandemic, COVID-19 starter kits, and we have additional resources as well, and some motivation on why we're focusing on COVID-19. And then, of course, we have the other one, which is the climate change, which also has some starter kits to enable you to follow up if you're interested in water sustainability, energy sustainability, or disaster resiliency. Now, I just wanted to also let you know that the deadline is July 31st, and so we don't have very much time left. But one of the things to note that is pretty important when you participate in a hackathon, that you actually create a solution that is realistic and shows that you've put in some thought into the solution that you built and taken into account realistic considerations. And for that reason, we're very delighted today to have our two speakers who are going to talk about realistic data sets, real data sets that they offer for their partners and for their clients, and which you're going to be able to have access to as a Call for Code participant. So I'm going to first start with Jay Couture. Anthem Digital Data Sandbox is the topic he's going to tell us about. Jay is Director of Innovation at Anthem. And so, Jay, could you tell us a little bit about Anthem and what you do?
Absolutely. And thanks for having me, Susan. So Anthem is one of the largest health insurers in the US and the largest by commercial membership. And at Anthem, we are committed to radically simplifying healthcare for stakeholders such as our consumers, employers, and the community, while improving consumers' lives and making healthcare more affordable and more accessible. So our vision is to be the most innovative, valuable, and inclusive partner in addressing the challenges that are facing healthcare today. I'll add as well that as a digital-first company, we use data technology and artificial intelligence to generate holistic and actionable insights and to personalize the consumer experience and help achieve better health outcomes.
That's great. And I believe that you've started running hackathons. Is that right?
That's correct. We've run two, as a matter of fact, one in the fall in Palo Alto, and we ran a virtual global hackathon more recently this year, running from January through March. And we had a lot of folks in Israel participate. We actually have an office in Tel Aviv. There's more information about what the winners were focused on, and specifically the challenge was issued around breast cancer and taking a look at the recurrence of breast cancer using machine learning. So I can put a link in the chat or share afterwards to the challenge page that talks about what the winners were focused on. And the winners were Clalit Research Institute, a health maintenance organization in Israel, and a company called Generation Gap.
That's very, very good. And so it seems like you've now moved on to actually get involved with other hackathons as well, like Call for Code.
That's right. We find that engaging with the ecosystem and the community outside of our four metaphorical walls and with our partners like IBM allow us to bring in outside perspectives to help us solve some of the biggest thorny problems that plague the technology and healthcare industry as a whole.
I see. And you have specifically something called the Digital Data Sandbox, right?
That's correct. We do. And I think we actually have a video queued up, a quick video to give a little intro for the Digital Data Sandbox before I talk about it.
At Anthem, we're working hard to improve lives and communities and making healthcare more proactive, predictive, and personalized, while also bringing down costs. Uncovering insights buried within data is key to understanding how and when to apply the right healthcare services. Traditionally, insights within data have lived in carefully protected silos inside a black box, which made them expensive and time-consuming to uncover. So we created a secure digital data sandbox containing a certified de-identified data set of more than 45 million unique lives spanning over 12 years. As the first free private healthcare data set ever made available to vetted users, we invite you to discover insights buried in the sand. Sandbox users can bring their own algorithms onto the cloud-based, scalable platform that protects user intellectual property. Data is made available in a lockdown environment for use with state-of-the-art data science tools to mine for meaningful insights. You can develop algorithms and validate solutions for deployment in the real world. Not only can we reduce costs and provide more access and a higher quality of care, but we can reveal insights and solutions to healthcare's most complex issues. Join us as we begin to explore the infinite potential of these connections. Just bring your big ideas, algorithms, and curiosity, and together, we'll change the world.
That was a great video. So you're going to tell us more, Jay?
I am. Thank you. So as we had kind of noted in the video, we at Anthem, and specifically in Anthem Digital, understand and are working towards making healthcare more proactive, personalized, and predictive, and also less expensive. And one of the ways in which we're doing this is through the platform that we have, which is called our Digital Data Sandbox. And on this platform, we leverage one of the world's largest certified de-identified private healthcare data sets. And Anthem takes the safeguarding of data and the privacy of personal information of our consumers very seriously. Identifiable member data, such as protected health information and personally identifiable information, are not part of this environment. All the data is certified as de-identified before it's included, so that it's HIPAA compliant and has quite a few auditability and privacy controls, which I'll get into in a little bit. And with this environment, our goal is to A, run hackathons, B, validate the value propositions of data-driven startups, and C, collaborate on research with academic institutions and folks who are interested in doing that kind of work with us. And it's really important to us that we've democratized free access to one of the largest private US healthcare data sets to pursue true machine learning and deep learning use cases with CPUs and GPUs on the cloud, to do insight generation and work with some of the smartest minds across the world, outside of the US, inside of the US, and also with some of our partners. So to date, we've engaged over 100 users on the platform this year. With more than 20 organizations, we've completed the hackathons that I mentioned, and we have over 11,000 hours worth of development time spent on the platform in 2020 as of the end of May, as a matter of fact. And we're continually working to expand the breadth and the depth of the data set that we have to support more and more use cases and things like call for code. The more data that we can provide, the better that we can support working towards some of these challenges that will help people be healthier as a whole. Now, as I had mentioned, it's a cloud-based platform. It's private, it's very secure, it's scalable given the nature of the cloud-based architecture, and we provide full training, support, and guidance as folks are onboarded to the platform. Now, within the platform at a high level here, we've got a total of more than 45 million unique lives worth of data across 12 years. And you can see the breakdown on the right of medical claims versus prescription claims versus lab data. And here's a little bit of a deeper dive on the data itself. So we've got very strong, high quality claims related data. We actually have currently over 6 billion claims in this environment. We've got very strong oncology related data as well. So things like regimens, biomarkers, oncology drugs. And as a matter of fact, in a couple of weeks here, we will be refreshing the claims data that we have through the end of June. So of course, diagnoses that are going on related to the current pandemic will be a part of that data set. We're also adding dental and vision claims to enable additional use cases, as well as some light membership demographics, such as gender codes, marital status, 2-digit zip code, what we are allowed to provide given the certificate of identification. We're also providing additional provider data, metadata from our call center. So information about who called, when, what did they call about, how long did the call last. We're adding about 5 million commercial electronic health records in our clinical domain, as well as benefit packages information. And the last thing I would mention here is that we've also added quite a few public data sets into our environment to help folks do unsupervised learning and allow their algorithms to do the feature engineering for them as they work with our real de-identified data. In addition to that, we provide the code dictionaries. We have licenses for the copyrighted and protected code dictionaries, so ICD-9 and 10, CPT codes, national drug codes, and HCPCS codes. So when folks want to get access, and again, we provide this access free of charge. It does not cost anything to access our data and work on our platform and our environment. Folks register, which they can do on the website. We'll provide the link to the website and show that in a little bit. And then on their side of things, we onboard them and define the use case. And then folks build on the platform. They do their development. And then we deploy the solutions that are developed. On the Anthem side of things, we curate the use cases. And of course, when folks go to apply, if they mention call for code, that ties all of the internal process here to the call for code use case. And we sign some very light legal documentation, which essentially states that folks are not going to try to break the platform or try to re-identify the data in any way. And we enable them by provisioning the data that is relevant to the use case that they're looking to target, as well as any of the code packages and technologies that they would need for folks to come into the environment and start building. Now, here's just a quick overview of the actual technical specifications of the environments. It's built on AWS. So of course, there are tons of options in terms of the number of CPUs and compute power, as well as GPUs that we can make available. We also, as standard, give about 0.5 terabyte of Redshift storage to work with our data, which can be increased. And we actually allow folks to bring their own Docker containers onto our platform so that they can score and train the models that they've already built on our data. And when we set up these environments, on the left side of the screen here, you can see we've got Windows workspaces as well as Linux workspaces. That's really a user preference and which technologies we have enabled within those environments. So essentially, when folks come in and they want to install some of their favorite data science code packages, they can do a simple pip install of a huge list of Python code packages. And if there's anything else that they would want to bring in, we can work to do that as well, especially anything that's open source. It's very easy for us to enable that. So the goal here is for us to provide a data science and development environment that is very familiar and feels like home to our developers and data scientists. Now, a quick point about the security. The internet ports are closed. So from within the workspaces, folks cannot access the internet, and that is to protect our data. And folks cannot copy and paste outside of the workspaces, and they need approval from Anthem to be able to take anything out of these workspaces. And as a rule, we don't allow our data to be taken out of the environment to ensure that our member information is fully protected, even though it's certified as de-identified. Now, a quick look at the actual interface itself. It simply just looks like a desktop. We provision the virtual machine and folks access it within their browser. So all of the database connection strings are pre-populated, and it's really easy to just hop in and start working with the data. So with all of that said, I would plug our website as a way for folks to come get access to the data. We will share the link. It's also anthem.ai/sandbox. And at the bottom of the page, there is a form where you can give us your information. Your information will come directly to me and my team. And I would please ask that you mention Call for Code as part of the organization or somewhere on the form so that we can align the use cases to Call for Code as we go through our vetting process here.
Thank you. Thank you very much, Jay. I wonder if you could go into full screen to make it easier for people to read. Is that possible? I'm very delighted that you've made this data available to the Call for Code participants, because this is real data, and so they're getting access to something very, very special. Well, thank you so much, Jay, for sharing this. Do you have any final remarks?
Yeah, thank you, Susan. Absolutely. I certainly hope that folks leverage this asset as a way to further their solutions for Call for Code, the various things that they're working on, and also want to let them know that this is available as a resource to them after Call for Code ends as well. For folks to get access to this data and to do so for free, it's very important for us that we've taken and protected the very large amount of data that Anthem has and is making it available for folks to work with us on solutions that are going to help better the lives of our Anthem members and improve health outcomes.
Thank you. Thank you so much, Jay, for taking the time to share this information with us, and indeed for making the data available to Call for Code participants. Now we'll move on from the presentation from Jay from Anthem and to talk about the IBM Pears dataset with Hendrik Hamann, Chief Scientist for Geoinformatics at IBM.
Yeah, we're building data platforms out which deal with geospatial information, geospatial data sets. And one of the big challenges with these data sets is that they're often really big, difficult to deal with. They come at different spatial, temporal resolutions, projections. And we build technologies which help data scientists, clients, developers to build geospatial applications on top of this platform.
Okay. And I believe you're going to be talking specifically about IBM Pears.
Exactly.
And do you have, is there, like Jay showed us a video earlier, is there a video for Pears as well?
Yeah, of course, we have a video for Pears. Okay. And so meet one of my colleagues, Johannes, who shows up in this movie. And it's a great introduction to tell you what this platform, what this technology is about. Could we play it?
My name is Johannes. I'm a research scientist at IBM's Watson Institute. Most of my work relates to geospatial big data. So think about things like satellite or drone images, cell phone data, social media data, housing prices, census data. It's very hard to search across it efficiently. Our group is developing a big data platform to effectively process this data and gain insights from it. This is a cloud-enabled service that allows you to develop insights with very little time and very little effort. Let's say you have an app that helps people plan vacations, and you would like to, make this app sort of data aware. So people choose their vacation target based on some information like weather, restaurants. We allow you, by combining your app with a cloud service to just very easily add this data. When it comes to using the platform as an analytics service, you tend to try to do forecasts, or you tend to discover some sort of clusters. The sort of questions you ask with machine learning and AI systems. One example you might think about is disaster response. You're trying to predict what areas will be affected by a wildfire. And this is an analytics problem that relates to where is the fire now, which is satellite, sensor data, possibly even data from phones, tweets, what people are reporting. But then, to see how this is going to spread, you definitely need something about wind, not just the wind right now, but also a weather forecast for a certain amount of time. There are many advantages to the platform. Once the data, is part of our system, it's all in the same projection, it all speaks the same language, and you can cut through it, in really very little time at high speed and get the information you want without having to worry about all these data preparation steps. Our vision is to give you a speed up that is basically from months to minutes, given the time it takes you to get insights and finish your projects. Whether you want to use this as an information service, as a discovery service, or as an analytics platform, it's always the same API. An important aspect of the platform is its scalability. Both analytics, as well as simple queries, scale to almost arbitrary large data sets. At the end of the day, this really allows you to worry less about the data and actually do your work, which is making discoveries, building applications, and actually advancing your projects. In our experience, we find that since big data really permeates all parts of life, it brings value to almost all projects, to industries as diverse as insurance, finance, agriculture, but also to small startups and individual people.
Well, that was a nice video. Are you going to tell us a little bit more about the Pears data set?
Yeah, absolutely. So let me share my screen, and let's have a look here a little more under the cover. So Pears can be accessed via a UI, and it is for first-time users probably the best way to learn about the technology. And so that's what we're doing here. We're going to the Pears UI, which is a rather simplistic UI, but designed to really help with the use of the technology. The very first thing you want to do as a data scientist, you want to look what data is available. So Pears has geospatial information. We have over 6 petabytes of data. It goes all the way from climate data to COVID data. We have a really rich catalog of these different data sets. As Johannes already described, all these data sets are curated. They speak the same language. They're spatially, temporally aligned. And for a lot of geospatial problems, that's exactly what you want. You can search these different data sets so that, for example, you want to look for COVID. There are a whole set of different data sets. Different data sets have different data layers. This is a geo-coded newsfeed data set, which looks for COVID-relevant information. There are different COVID data sets from different universities, from different health agencies, etc. So that is the first step. You're looking at all the data you could play with. Now, let me give you one example, and let's take how you can get started. Let's take a weather data set. This is weather. This is actually historical weather information. It could be actually quite interesting for climate applications, because if you want to understand the change of climate, you also want to understand, of course, what happened in the past to the climate. So this is a really interesting data set, which you can just play with here in this UI and spin up a query. And these queries are always designed in, you want to get some information. So what is it? What data layers? So this is where the data catalog comes in. You can specify where do you want to get the data. So let's say you want to get this for California. We have different polygons you can search for. It will tell you how big the data set is. You can specify a time range. So let's say we go back to 2011, you would see there's now 366 data layers, which means these are all different time steps. These are basically the numbers of days. And here we're talking about 56 megabytes in this particular case. You would then basically specify some aggregations, do some math, spin up the query, and it would eventually show up in this query page. So I ran this earlier for you, which is here the temperature profiles across California. This is actually the rain, and you can click here at every other place and explore the data. Before we go into a little more interesting example, let me just give you 2 pointers here. So we have a rich set of documentations. Most people don't use the UI, of course. They will be using the API. There's a description of the API. There's a description of the UI. And there is also a Python wrapper, which we will be using in a second. So there's a rich source of information here, which hopefully can get you guys started. Okay, so now let's take an example, a little more interesting example. Right, so the call for code is about climate change, and of course around COVID. So I was thinking, let's create an example and to show you a little bit how pairs can be used to understand what is the impact of the COVID-19 crisis on the climate, right? That's an interesting question to ask. And I will show you how you can do this in pairs with just a few lines of code. So for that, we will be using a notebook. You can obviously use your Watson Studio, for example. Here, I will be just using a Jupyter notebook from Anaconda. And the question we're really asking is, how many lines of code do I need to observe the impact of COVID-19 on climate and pollution? And so how do you start? Well, you go to the data catalog and you think about, okay, what kind of interesting data sets are available? And one data set, which is a satellite data set, which is available, is a satellite which measures pollution levels around the globe. And you can easily query that data set out, right? And here's what we do. We get ourselves some credentials. We get ourselves, we basically use the Python SDK because it gets a little bit easier. You see here, this is a data set ID. We specify the area. This is the pollution data set, which is nitrogen dioxide. Nitrogen dioxide is basically a gas, which is, it's a pollutant. It contributes to greenhouse effects, and it's actually being generated in the combustion. Whenever you combust something, you drive a car, you heat, it's actually being generated. We submit this query, so it's not very complicated. And then eventually we get the data set back. So let me show you how that looks like in the Pairs UI, because it's a little bit easier to look at this. So when you submit a query, you might get something like this. And you really wonder, what on earth is this, right? We specified the whole globe. But the interesting part here now is that this is actually the satellite flying across the globe. Remember, the Earth is round, and so it's basically a swath, and it's just one timestamp. So basically, at this particular timestamp, when I queried, this is what the satellite did. It created this swath across the globe, and here we are on the other side, right, of the globe. Now, in order to get something meaningful from all this, we do a little bit more, right? And here's what we do is, we're basically taking all the timestamps for the month of February. Remember, February, the COVID-19 crisis was in most parts of the world not really realized. And now in April, of course. So we take everything for February, we take everything for March, we take everything for April, and we aggregate that data. Now, if you run through this exercise and you would think about how many timestamps and how many data sets you would need, you end up with 1,200 data sets, or 180 gigabytes. Now, the beauty of Pairs is that you can submit yourself a query, and that query is in ways which allows you to do the integration for February, for March, for April. And it then basically publishes this directly back to the Pairs UI. This query, if you would do this, if you launch this, it would take 6 to 7 minutes. If you would download all the data, it would take you 24 hours. So let me show you how this looks like, which is sort of the exciting part. So you remember, now we had initially these stripes. We actually aggregated the information for February, for March, and for April. And in February, you see now the pollution levels pretty clearly, right? And it makes sense. You see there's a lot of combustion, a lot of pollution here in North America, mostly on the East Coast. These are the oil sands in Canada, a lot of pollution in Canada, a lot of pollution in China. So that's how it looks. This is how it looks. And this is the actual production of nitrogen dioxide in the atmosphere. Now you go forward to the month of April, and you see this vast reduction in pollution. At every one of those places, you can see pretty much everything is come down. So it is an example what cool and interesting and exciting things you can do in Pears. And maybe, Susan, you have more questions?
Yes. One thing we should mention is how people get access to the Pears dataset, and they need to send an email to pears@us.ibm.com, right?
Yeah, so you are completely right. It is, there is a process here and it looks complicated, but to be honest, it isn't. So just send an email to pears@us.ibm.com. Say you are a participant of Call for Code. You include your name, your email address, and your company. And then you will get an invitation, and then there's a series of simple steps you can follow to get access to 7 petabytes of geospatial information. A lot of that is COVID related. A lot of that is related to climate change. So it's a rather simple process.
It was interesting that you managed to find an example that covered both tracks of Call for Code. Both the COVID-19 and the weather and the climate change, and I think a team doing that solution would have to think which track to submit to. Probably the climate change, I would think.
Yeah,
that would be just my thought. There is a comment on containerized apps in Kubernetes and cloud native apps and real-time deployment. This talk isn't really today's session isn't really about it's more about the data. It's not really about the app deployment, and there's nothing to prevent app deployments in containerized apps to be deployed using these data sets. Am I right?
Yeah, you're absolutely right. So if you and again the example I showed was sort of in a local environment, but of course you can run everything I showed from IBM Cloud in IBM Cloud with Watson Studio, deploy it and so on and so forth. Yeah, no problem.
No problem. Are there any other questions or any other final remarks from you?
No, I think that's. I hope people have fun with it, and so that's all. That's a big hope.
Right. I wonder, I'd like to just quickly show to remind people about the getting started with Call for Code. So you've heard about 2 wonderful real data sets that you can get special access to. The one from Anthem and the Digital Data Sandbox, and the one from IBM Pears, and it's very unusual. I'm very lucky to get access to these data sets. And just to briefly go over the getting started, if you haven't got started yet with Call for Code, there's this page called Get Started, and you have to get your submission in by July 31st. You have to accept the challenge. That's your first step. So you register to accept the challenge. And then you choose your track, either the COVID-19 track or the climate change track, or as the example we just had, sort of somehow transcended both tracks, but maybe, you choose the one that's most appropriate to you. And then this is the timeline. As we said, it's July 31st to to finish up, there are some, also you can find other team members through Slack. So that's one of the best ways. If you're looking for other people to collaborate with, you can also look for events that you can there's a lot of virtual events around Call for Code, and then you submit your solution, and the prize is amazing if you were to win, around $200,000. And you have to provide access to your code, and you need to create a 3-minute video, which the judges will use to rank you alongside all the other participants, and also will examine the code that you provided. And having access to these kinds of data sets is really wonderful to create a realistic solution and demo. And there's a submission checklist that you can look at, and then you can submit. I think that's all we had for today. I think we'll end the session. I'd really like to thank Jay Couture and Hendrik Hamann for the wonderful descriptions of the data sets, and indeed both the digital data sandbox from Anthem and the IBM Pears data, really beyond the data set. There are just many data sets, and offer a plethora of solutions, and provide inspiration for a lot of new ideas around Call for Code. So thank you very much, Jay and Hendrik, and goodbye, everybody.
Thank you.
Thank you.